Logarithmic clones of the golden ratio. My motto: plain honesty, simple truth, easy understanding, the joy of finding things out for yourself. Way back in the late 1970s, early 80s, having just discovered the golden ratio and being in possession of a Texas SR56 programmable calculator, advanced tech for the time, I sort of realised that there should be the logarithm of a number and the number itself that both had the same decimal expansion. Lo and behold, I found not one but two, one for the natural logs and one for the base 10 logs, and I duly recorded them in my little red Mao Zedong book, and which, lo and behold, I still possess. The results are at the top of the page, above, believe it or not, my notes on the golden ratio. I can't remember exactly how I set about finding them, but after a bit of trial and error I found it was extremely easy, although slightly confusing, with a present-day scientific Casio calculator, and in the process found out a little bit more about these interesting, magical, yet useless numbers. Proceed as follows. With answer equal to a arbitrary seed value, I used 0.7, enter the expression e to the power x, answer reciprocal, and repeatedly press the equals key, in this case 40 repetitions, until a constant value of plus or minus 1 in the last digit is obtained. 2. With answer equal to a seed value of 0.7, enter the expression 10 to the power x, answer minus 1, i.e. reciprocal, and repeatedly press the equals key, in this case 246 repetitions, until a constant value of plus or minus 1 in the last digit is obtained. The confusion I referred to was that I didn't get the numbers I recorded way back then. However, this was sorted after a bit of trial and error, as shown in the table, where we first obtain the constant number, then taking either its reciprocal or logarithm, we obtain the value I obtained way back then, which I recorded in my little red book. Taking the logarithm of the second value gives the negative equivalent, the reciprocal of which gives the negative value of the number we started with. Taking plus or minus the number, and we are back where we started. Running a small program in Precise Calculator, I discovered why I got different answers now compared to way back then, since Precise Calculator just gave the two intermediate values as per my past results. To get the full result I am getting now, the reciprocal action is carried out on the index ANS before the antilog action. In order to get the partial result I obtained way back in the late 1970s, early 80s, we carry out the reciprocal action after taking the antilog by separating the two with brackets as shown on this slide. I have also shown in item 4 an alternative way of carrying out the iteration via a recursive equation. So have fun trying it out for yourself, and I hope you enjoyed this numerical revelation. Thanks for watching.